guys, it's me, Shiwo.
Me, Asher.
And me, Makayo.
Today on Shiwo Science, we are literally out on the field, and through tests and demos, we are going to find out the physics behind soccer shots. So, let's jump right into it. The first shot we'll be discussing today is the infamous curve shot. Many professional soccer players are famous for elegantly curving the ball right into the net. But what physics are actually in play in this crazy, awe-inspiring shot? The answer is the Magnus effect. When a soccer player makes a curve shot, or a banana kick, as it is informally called, the Magnus effect comes into play, creating unequal air pressure on both sides of the ball. This imbalance causes the ball to take the easier path, curving towards the side with less air pressure. If there are pieces of turf or grass on the ball, this makes it further unpredictable and hard to catch for the goalie, in some cases almost impossible once soccer players have mastered the skill. The next shot we are talking about is the dip shot, when a ball looks like it's going to go just above the net, but at the last second it dips down and makes it in. This happens because of the ultimate G-force. That's right, gravity. As the ball comes close to the net, gravity eventually starts to tug more and more on it, creating a sort of force field where it is forced to dip down. The next shot we will be talking about is the free kick. Now, the free kick is an interesting aspect of soccer, as it can ultimately play out as being any one of the kicks we have discussed previously in this video, and even other ones. But what is the science and physics behind a free kick? Well, first let's look at what a free kick really is. The collision between the ball and the foot from a specific distance, with added friction from the grass. The truth is, the physics behind a free kick and how to score a perfect one are all in the amount of friction compared to how far you are from the net. Together, we can find a perfect formula for these two, which would make for the perfect free kick. But as you probably know by now, we can't really do that in the middle of a soccer game. That is why there is no perfect strategy for somebody in a professional soccer game to always land their free kicks. The next shot we will be talking about is Pele's famous bicycle kick. Now, the physics behind the bicycle kick is that your feet have to be like the blades of a helicopter, rotating around a single axis and not stopping once you have touched the ball, but instead maintaining some drift so that the ball can go right in that net.
The bicycle kick is one of the most amazing displays of physics in soccer, as your body becomes almost perpendicular to your leg.
The next shot is the toe punch, known by soccer players all around the world. Even if you're not dedicated to soccer, you've probably heard the term before. Now, the toe punch physics are actually quite simple. As the kick hits the ball, the speed and power of the ball when it is kicked in that way is simply stronger than any other kick. The toe punch speed is very efficient and related to physics because it minimalizes the friction with the grass. So the ball almost glides along without even touching the grass. Of course, it is touching the grass, but there is minimal friction. It's not rubbing against it as it would in other shots such as passes.
See you next time. But before I go, if I miss this, then you have to like the video. Oh well, I guess you're off this time.
Like the video anyway, okay?
No, shut up.